Welcome to a lesson on same-side interior angles. This is the one relationship that is a little bit different than all the others we've examined. So far, the ones we've examined, the angles have been equivalent in their measures. In this particular example, the same-side interior angles do not have equivalent measures. So interior, meaning inside the parallel lines, same side, meaning on the same side of the transversal. We again have two pairs. Our first pair that we're going to look at here is angles 6 and 4. Those are inside the parallel lines on the same side. You can even see visually they do not have the same measure. The other pair is 5 and 3. Again, those are on the same side of the transversal and inside the parallel lines. So let's take a look and see what the relationship actually is. So from a previous theorem, we know that angles 6 and 2 are corresponding, so they have equal measure. So that's good to know. And then it must be true then that since 2 and 4 are a linear pair, they would add up to 180 degrees. Let me write that down. The measure of angle 2 plus the measure of angle 4 is equal to 180 degrees because they're a linear pair, right? We also can then conclude that it must be true that measure of angle 6 plus the measure of angle 4 equals 180 degrees. And that's true because 2 and 6 are equivalent, right? So I know that these two same side interiors must add up to 180. Let's use that in problem solving for a couple different problems. So here, there's a couple ways to approach this. You could figure out pretty quickly the measure of angle 1 is equal to 66 degrees because it is an alternate interior angle to the given angle there of measure 66. You also would know that since angle 2 is on the same side and interior to the 66, that the measure of angle 2 plus 66 degrees must equal also 180. They're supplementary. If you use a little subtraction there to figure that out, subtract 66 from 180, let's see, we get 114. So that would mean that the measure of angle 2 is equal to 114 degrees. Or in other words, 114 plus 66 equals 180. Let's look at a specific algebraic example that I have here from our text. In this diagram, you can see the two angles marked are same side interior. That must mean that their angle measures have a sum of 180. Writing the relevant equation, we get that 2x plus 43 plus the other 2x minus 3 must have an angle sum of 180 degrees. So dropping the degree symbol and simplifying, we get 2x plus 2x is 4x. We get that 43 take away 3 is 40, and we have 180. If we subtract 40 from both sides, we get this, and then dividing by 4, we should get that x is 35. We always probably want to check our answer or at least see how it makes sense. We want to find the measure of those angles. So plugging in 35 to the top expression, 2 times 35 plus 43, 2 times 35 is 70, plus 43 would give us 113 degrees, if I didn't make a mistake there. Plugging into the bottom expression, we have 2 times 35 minus 3. 2 times 35, again, 70. Take away 3, we have 67 degrees. And the way we can feel pretty confident that we have it right is, do these two angles have a sum of 180 degrees? It appears that they do, so it appears we have done it correctly.